express this function in the form of partial fractions. Solve the differential equation that's given here, where y equals 0 and x equals 0. Expressing your answer in the form like this, where p and q are constants. So I've written down the question in summary here. So let's have a little look at this then. Right, okay, so we've got to use partial fractions for part A. So here we see that if that's the case, if this is equal to that, then multiply through by the denominator gives 1 on the left is equal to A times the 3 minus 2x will cancel and the 1 minus x bracket squared will be left, plus B. Just one of the 1 minus x's cancels, and we've got the other two terms, haven't we? Plus C, and here we're just left with the 3 minus 2x bracketed term. So that's what we've got then, so let's put in x equals 1. And that should be the easiest thing to put in for the most part. 1 is equal to, put 1 in here, 0, 1 is 0 here. So it's just this term here. 3 minus 2 is 1. C times 1 is C. So C equals 1. So there's the value of C. Now x equals, so let's put in 3 over 2. It's the next easiest thing to do, really. So 1 on the left is equal to, put 3 over 2 in here as 0, and here is 0, so it's just here. 1 minus 3 over 2 is minus a half. Minus a half squared is a quarter, so that's a over 4. So that tells us then that a equals 4. We'll remove the 4 from divide up to times. 4 ones are 4. So there's a. Now, if we equate x squareds, there'll be no c term, will there? We can get b then. So we're equating x squareds, both sides. None here is equal to, and this is an x squared when you expand this bracket, so it's a, lots of x squareds. And here we're going to have 2x squareds times b, which is 2bx squareds. So that's 2b. There's no x squareds here. So b will equal minus a over 2, so it's minus 4 over 2, which equals minus 2. So there's b equal to minus 2. Okay, good. There's b. I'll just put a proper box around it. There we go. B equals minus 2. So that's the answer there then. So you'd write out this afresh. A is 4. So I'll put them in at the top here because it's already been written out. So it's 4. B is minus 2. So I'll put it in here. And C is equal to 1. So we've got our partial fractions then. Okay, good. So now we turn our attention to the next part of the problem. Solve this differential equation, y equals 0 when x equals 0, and write the solution in this form. So differential equation then, dy dx is equal to 2 root y times the g of x function that we had. So that tells us then separating the variables and integrating gives the dy can stay as is. Move the root y down, so it's 1 over root y, which is y to the half. Move the 2 down as well, but I'll put it outside the integral as a half, equals the g of x we can write as the partial fraction now. 4 over 3 minus 2x minus 2 over 1 minus x, and then it's plus 1, isn't it, over 1 minus x squared, bracket squared. The dx can come up to view with it now with this g of x function, and we've got an integral here. So integrate then, y to the minus half integrates to y to the half over half, but the half underneath will cancel with the half on top, so we don't need to write it. This will be log of 3 minus 2x. Log of something differentiates to 1 over something, multiplied by the something differentiated, minus 2. We want to get rid of the minus, and we want to make it 4, so put another 2 in there. Here, this is ln of the something. Differentiate this 1 over something. The minus then comes out, so we don't need to worry about a minus, but we need a 2 lots of, don't we? And this will be 1 minus x to minus 1. When we differentiate minus this to the minus 2 multiplied by the something differentiated, minus times minus becomes a plus, so we don't need to change anything there. Plus our constant of integration. So y to the half then is equal to 2 ln. I'm going to use properties of logs because the 2 is common here, and it's this take away that log, so it's 1 minus x over 3 minus 2x is these two terms here, because we had two lots of, and it's this log take away that log, so we do the divide rule, plus 1 over 1 minus x plus k. So that's what we've got then. Put in the initial conditions. Y equals 0 when x equals 0 gives, so we've got 0 to the half is 0, 2 ln 1 minus 0 is 1, ln 1 over 3, 1/3, plus x is 0, so this will be 1, plus k. So that tells us then that k is equal to, move this over there, it's minus 2 ln of 1/3 minus 1. So k is equal to then, move this, flip this upside down by taking the minus up here. So it's 2 ln of 3 minus 1. There's k. So y to the half then is equal to 2 ln. The k here is 2 ln 3, so basically you can put the 3 in here because it's plus, isn't it? Plus 2 ln 3, so it will be equal to 2 ln 3, 1 minus x, over 3 minus 2x. So all we did there was in our mind's eye, that 2 log 3 was here. We collected the 2, and then it was plus log 3 times this log. So it's just 3 times n times you add for the logarithms. Plus this, 1 over 1 minus x, and then minus 1, which is basically minus 1 minus x over 1 minus x. So that's what we've got. Then I'm just writing the minus 1 so that I can collect the fractional terms together as this over this. So y to the half then is 2 ln 3 1 minus x over 3 minus 2 plus, now here we've got 1 minus 1 goes, but plus x is what's left because there's a minus runs through both terms, over 1 minus x. So there's our final answer then, and then if we compare it with what we've got above, looks good. P will be a half, Q will be 2, P will be a half, and Q is equal to 2 in the above.